Welcome guys, here to another tutorial series. What we'll be discussing today is basically door lock system. So today we'll be discussing keypad door lock. So basically, as you can see, this is the entire setup. This is the 4x4 keypad. This is your Arduino Uno. This is your I2C display. This is the servo motor. This is the mechanical lock. So today, what we'll be discussing mostly is you're going to be centered around this lock here. As you can see, this is a mechanical lock. In our next tutorial, we'll be using a solenoid lock. In the first one, we did it using just this servo motor. So once the right password or pin is entered on this keypad, the doors unlock or lock. As you can see, it is saying enter password unlocked. The door is right now unlocked. As you can see it here is unlocked. So right now let's key in the password and see. So key in the password. Now as you can see, the door is locked. So now if the password is keyed in again, so just follow with me. Now the door is opened, say unlocked. So I'll just zoom out a bit. So you see it. While it's still there, I'm going to try and unlock the door again by entering the password. Now it is locked. Now here on this keypad, this breadboard here, there's a button. Assuming this is a design in an home, for example, you should have an easy way to lock in your door once you're inside. So this button here locks and unlocks the door. Once you press it, it locks and unlocks at the same time. So this one gives that easy way out. Instead of entering password all the time, you can just tap a button and the door locks and unlocks behind you. So basically, this is how this system works. This is the entire wiring, which I'm going to be explaining to you step by step in the next phase of this tutorial. I'm going to be showing you how to wire this as well, same as this button and this. This is basically the power supply that supplies the entire unit's power, as you can see. So let's just dive into the connection. Once we're done with the connection, we'll upload the code to the Arduino Uno. This is the SMD version of it. In the first one I used the Arduino Uno, the original one. This is more of a Chinese version of it. It still works perfectly, it does the same thing, so there's really no issues with it. Everything works well, so that's what matters. So right now let's just dive into the connection proper. So guys, what we'll be doing right now is basically just to make sure you understand how the connection of the video you watched was done, because the student who requested this project to be done needed to understand how the connection was done from Arduino to the IC2 display, the keypad, the servo motor, and the push button, which are the basic components of this whole system. So basically, now before we start the connection properly, I need to explain something to everyone who will be watching this video, because basically there are different steps in which you can achieve this. It doesn't really matter which one you do first, as long as all connections are done properly, the codes are uploaded, it should definitely work. But before then, I have a key here talking about the keypad, which is one of the most complex part of the connection of this video tutorial. So right now, this is the keypad. As you can see, it's a 4x4 keypad. You have 1 to 9, A to D. You have your star, your hash, and all that. Then 0, But basically, those are just the figures on the keypad. What we are concerned about are the pinout of this keypad. Right here, these are the pinouts of the keypad itself. We have separated into two parts here, as I did. We have arrow 1 to arrow 4, C1 to C4. Now, the reason for this, arrow 1 is the first pin of this keypad. Now, we have 8 pins we need to connect to make use of this keypad as far as this tutorial is concerned. So, like I said, the first one is the arrow 1, second one is arrow 2, third is arrow 3, fourth is arrow 4, just like that, sequentially to C4. Now, talking about arrow 1, this is the keypad pinout. This is the side, the pinout of the Arduino. Whether you are using Uno or not, these are the digital pins you need to use. Now, arrow 1 goes to pin 2 of the Arduino itself, arrow 3, arrow 2 to 3, arrow 3 to 4, arrow 4 to 5, like that, C1 to 6, C2 7, C3 8, now C4 to 9. Once this is connected properly using your jumper wires, that should go. So right now, let's just dive into the connection properly. Now, what I've done here is I've done the first connection. This is your I2C 16:2 display. This is your Arduino. Try to make sure the Arduino image is as clear as possible. You might be using Nano. You might be using the Pro Mini, but Pro Mini might not even work for this because of the pins you need for this, but Nano will also work. In this case, we are using Uno. As you can see, this is the pinout of the I2C 16:2 display. This is an LCD which is already converted to I2C using this module you see up here. Now, this module helps to reduce the wires that is needed. On a normal, you'll be needing about 8 to 9 wires connected to this Arduino in order for you to be able to interface with this LCD 16:2. But with this I2C, everything you need to do is just 4 wires. Basically, it's even 2 because every equipment you use needs a ground and a VCC. So basically, we are just talking about the serial clock and the serial data, SDA and SCL. So right now, what we need to do first, we connected the ground, which is the neutral wire. I don't know how you're going to call it, but ground is more of the neutral N. So you connect that to the GND of your Arduino. On this Arduino Uno, we have two ports for GND here. We also have another one here after pin 13 on the digital side of this PMW of the Arduino. So we've connected pin 1, which is ground of this I2C module, to ground of the Arduino. Now we're going to connect the VCC. So right now I've connected the VCC, which is to the 5 volts of the Arduino. Now, once you do this and the Arduino is powered, you're going to see this display come on, though it's not going to show anything, but the display is definitely going to come on for you to see. So the next thing we're going to do right now is to connect the SDA of this I2C. Now, SDA is connected to analog pin 5, which is talking about the ROTS and the ROS and TS. Pin 5 is the A5 is the analog pin that needs to be connected to this SDA. It is the serial data. Then for the serial clock, it's connected to A4. Now this is the serial clock input, which is this green, that will be connected to A4 on the Arduino. This is done this clear just to make sure you understand the wiring. So if you're going to be doing this, you just need your jumper wires with this equipment all handy on your table while you connect along as the video plays, or you can play it to a point like as I am right now on this point where all 4 leads of this I2C module is already connected. Then you pause connect them, then you move to the next. So what we need to do next, after this has been connected, we have to connect this keypad. Like I said already, this keypad key is always by the side for you to understand where it needs to go. Now, arrow 1 needs to be connected to pin 2. As you can see, arrow 1 here has been connected to pin 2. Arrow 2, pin 3. Arrow 3, pin 4. Arrow 4, pin 5. Now, move to C1, C1 to 6, C2 to 7, know that, C3 to 8. Now, C4 to 9. Once you've done this, the connection for the keypad is completed. What we need to move to now is our push button. Now the push button has, this Arduino push button has 4 leads. What you just need to make use of here is 2 of the leads itself. So you're going to connect one of the leads. It can be any of them. There's no polarity on this push button. You can connect any of them to ground. Then the other one will become the clock, the signal button, which will be connected to what? Your A0, the analog pin, the Arduino. Once this is done, the connection for the push button is completed. Now what we need to focus on is this servo motor. Now on this servo motor, I've done a little labeling in order for you to understand what is here. Note, VCC means power input. Ground means what? Ground input. Now, ground is just like your neutral, while VCC is the live wire carrying the voltage that needs to operate this servo motor. So the other one is your control signal. So right now, if you look at the pins here, I use these illustrations because if you're using this same servo motor or any other one, you might end up likely going to have the same color coding of these cables that are connected to the servo motor. Now the black one stands for the what? The ground. The red, so the VCC, while the one that looks like orange stands for what? The control signal. Now let's start with the connection. We always start with the power section, which is ground. Now I'm connecting ground to the ground of the Arduino. So you can see I didn't connect the ground directly to the Arduino here. That is because the Arduino ground is already looped to this point. So it's a common ground. I decided to hook it up here to the ground of this I2C. It's the same thing as you connecting it all the way to this ground here or connecting it to this side. It doesn't matter. If you know electronics, if you're even watching this video, it means you know the basics of electronics. So this shouldn't be an issue. The next is to connect the VCC. Now the VCC has been connected to the Arduino VCC plus 5 volts. Now talking about the control is connected to 12 of the digital pin of the Arduino itself. Now this control itself is what sends the signals once the right keys are pushed into this keypad. The door will open or lock. If it is open while the keys are punched in, it will lock. If it is locked while the keys are punched in, it will open. If the wrong ones are punched in, it will tell you access what? Denied, which will be displayed here on this LCD we have here. So basically, this is the circuit diagram of this whole video you just watched. Now, what we need to do now is to move on to what? The Arduino code upload, which I will be doing on the Arduino IDE. So right now, let's just move over to the Arduino IDE. Let's upload the code. Once the code has been uploaded, your device should come on. So guys, what we'll do right now is just open the sketch. This is the sketch for this project. I'm just going to open it. Mind you, you don't have to bother yourself with the sketch. The link to this sketch will be in the description of this video. Just need to click on it, download, do your wiring, upload to your Arduino, and run your test. see how it functions. If it works, drop a comment so as for others to follow. Okay, so now this cache is fully loaded. Now we just try to do a breakdown of this code as much as possible. As you can see, there are already write-ups. These are comments to explain what each of these rule does. Like here, it tells you this what helps to what adjust to match your what I2C address. This one talks about 4 row, 4 columns. Now this is the 4x4 we're talking about. This is the keypad section of it. But before that, there are some libraries which without it, you won't be able to even upload this code to your Arduino in the first place. The Arduino IDE has to detect these libraries in your library in order for it to upload. So the first one is talking about the wire library. This wire library is what helps to what do the wire conversion of this LCD, this liquid crystal, talking about the I2C. Now, usually this module of 16x2 LCD are what produced. Before now, they are always produced with in the way they are. There's nothing like I2C module attached to it. So what you need to do is do the connection manually. You start doing soldering and all that of header pins, female header pins just to attach to the male you already soldered to the I2C, the LCD display rather, in order for you to get the connection. But these days, to make things easy, those connections have been done using by doing a design of this I2C module, which helps to do all those wire conversion into just two, aside the positive and negative which you need to power the LCD itself. So basically, this wire library is what helps in detecting that conversion that has been done. Because without this library, the system won't even know you are connected to an I2C device. So this helps to do the conversion between the LCD display and the I2C module that is attached to it. So in this case, we have a 16 by 2 which we use for this project. That is what is addressed here, 16 by 2. Now there are others that are 16, 20 by 4 rather. You have about 20 rows, then the column itself is 4. So in this case, we're just using the 16 by 2, which you already watched in the video. So this library is what is responsible in handling this what LCD display that was used in this project. So talking about this, the next one, which is the liquid crystal I2C library. Now this library itself is what helps in displaying whatever signal you're sending to that screen itself. If you notice, when you do your connection and you power it on, there will be no display on the screen at all. Instead, you'll be seeing the matrix, the 16 matrices that are on the row and the 2 that are on the what column itself. But with the aid of this library, the signals that are sent there are converted into visuals for you to see. Now, the third one is keypad. As you can see, or as you already know, we use a keypad, which is the main center of this project. It's a keypad door lock system. We use a keypad which is 4x4 in this project, and without this keypad library, the system won't be able to even notice what you're doing. Even if you keep punching in the codes, nothing will happen. There will be no effect on it. On this keypad, if you punch one, it will show on the screen that you're punching one while entering the code itself. So that is why this keypad library is added in order for you to interface the system with this keypad. The last one, which is the servo.h, is a library that controls the servo motor that pushes the door open and lock. In this case, we use the mechanical lock to simulate our door lock and all that. So when you lock or open the door using the servo motor, there's a push to the left or to the right. It moves at angle 90 in order for us to get that lock and open sequence on the servo motor. So basically this one controls the servo that does that. So aside that, this adjusts the strings down to what enable this whole project work the way it is. In this case, this byte row pins talks about the pins on the keypad itself. We have 8, we have 9, we have 7, we have 6, we have 5, we have 4, we have 3, we have 2. We also have 1 on the keypad. So this addresses the entire keys on this keypad. So this one addresses the pins on the row, this one addresses the pins on the what? On the column. So basically the keypad itself is addressed on the system based on row and column. So aside that, this is just a string to set the password. Now on this system, the default password here is 1234. If you are doing yours, you can decide to change this to any password of your choice, and that is what the system will recognize when you key it in. Whatever is on this place when you do your upload is what the system is going to use as access granted password. So you can change this 1234 to anything of your choice as long as it's within these 4 digits. So this is just the area where the keypad password is set. This is the area for the servo motor, the push button. Like the push button has just 2 functions, an high and a low. Now the push button is there to help you mitigate the issue of having to punch your keypad all the time. Assuming a situation whereby you're running from intruders, you happen to get to your house after just getting into the house, you manage to punch it in at the entrance. After getting to the house, you have to start punching again in order for the door to lock. That is the essence of this button that is added to this project. What the button does is help you lock and unlock the door with just a push. So in a situation whereby you are running from an intruder and you manage to get in, you just need to hit that button. As long as the door is closed, it will lock immediately. And if you hit it again to open. So if you are inside the house, you don't need to start entering keys and all that in order for you to open or lock your door. The push button does the job for you. And this push button is meant to be indoors, not outdoor. It's only the keypad that will be outdoor for whoever is coming in. So that is this role for you. Now, aside that, every other thing here is something you really don't need to bother yourself about. What you just need to do at this point, select your board here. If you are using Arduino Uno, just select Arduino Uno, then your port. You select your port, after which you hit the upload button. This is the upload button here. Once you hit the upload button, it will start uploading immediately and you will see the progress on this session here. So once, let me just select a board so you see what I'm trying to talk about. Arduino Uno, since it was used on this project, let me select a port, select port 3. If I hit compile, now once I hit upload, you're seeing that it's compiling sketch and all that. So this is going to compile. Once it is done, I already aborted it, but in your case, you wait for it to compile completely, then upload the sketch. Once the code is uploaded, your system will come on automatically to start displaying unlocked. The system will just start on an unlock basis, then you can lock and unlock using the keypad and all that, as already explained in the video. So this is just the basic step in which you need to go in order to at least attain this project. So if you like what you just watched, like and subscribe, share to your friends, as this will encourage me to do more videos. And if you have a specific video you want us to talk about, you can request on the comment section and I will attend to that video upload for you to follow up. Thank you for watching. See you in the next video.